Hello, this is Nathalie Bonafé, and I'd like to welcome you to the Menopause and the Brain Part 1 webinar. My colleague, Dr. Sandra Rice, and I are going to discuss the role of estrogen in the female brain. A little bit about Dr. Rice. Dr. Rice has been practicing medicine for over 35 years and has decade-long experience managing perimenopausal and postmenopausal patients. She is board certified internal medicine specialist and is the author of the book, The Estrogen Question, Know Before You Say No to Hormone Replacement Therapy, published right at the beginning of the pandemic. She and I met last year in 2021, and we love working together on designing webinars for the general public. I am Nathalie, a former biomedical research scientist, now women's health advocate from menopause through the end of life. I believe that every woman has the right to know about options and possibilities as they age, and that it starts at midlife. I provide individualized education and coaching at nathaliebonafé.com. Dr. Rice.
Nathalie, it's great to see you
Hello.
again, and thank
Hello,
you so
Sandra.
much for coordinating this webinar.
Thank you so much for being here. It's always a pleasure. So in my practice, I often say that menopausal symptoms start in the head. But what I really mean is that it starts in the brain. And it affects our decision-making and how we live for the rest of our lives. It's like I speak a foreign language, which I do. And people are surprised. Can you help me break it down, please?
I'd love to. This is it's so important for me to help, as you, to help educate women about estrogen and what it does for us. And I think that a lot of women think estrogen is really mainly only important for those female parts. And let me pull up my first slide, if I may. And I think that illustrates the point that it's for the development of our breasts and our uterus and our ovaries, all those organs that make us uniquely female. And I think women don't realize that estrogen really does a lot of other things in the body. And the reason this is relevant is from my perspective, is that when it comes time at menopause, which is when, of course, the ovaries don't make estrogen, women at that point in their lives may think, well, gee, I don't really need estrogen anymore. I mean, I'm all done with having babies, and I'm perfectly happy not to have my menstrual cycles anymore, right? So I think they kind of say, well, when it comes time to deciding whether or not to take hormone replacement therapy, whether or not to take estrogen, that they tend to focus more on the negative things rather than the positive things. And by not realizing that there's so many good things in the body, so many functions that estrogen performs in the body. And just to illustrate that, I have the second slide just demonstrates where in a woman's body estrogens play a very, very important role. I think most women are aware that they're at risk for osteoporosis after menopause because of the loss of estrogens, but they may not realize they're also at risk for a loss of muscle mass, the same issue. Estrogen works on, helps maintain our collagen. Collagen is the basic building block for our skin to help it be more moist and elastic, but it also is the building block for our joints. A lot of women do get joint pain after menopause. They don't realize that, oh, that could be because of the loss of estrogens. And even voice changes happen after menopause because of the effects of the collagen. Estrogen plays a huge role in the way our fat metabolizes things and how the fat has a role in energy production and utilization. And another major area where estrogen plays a role throughout our lives is on our blood vessels. It helps keep plaque from developing. And this is why women tend to have lower risk of heart disease than men until after menopause, where their risk of heart attacks increases. So estrogen plays a huge role in many areas of the body. And last but not least is the brain. We are going to focus our talk today on the brain and how estrogen is so important throughout our lives, and what happens maybe not having estrogen for the last 20 or 30 years after menopause.
So how do we know that estrogen works in all these areas?
That's the scientist in you, Natalie, which I think it's really important for women to understand this. I mean, we can sit here and tell women that you need to take estrogen or estrogen is good, but we got our goal, I think, is to have women understand exactly why. So in order to really help describe what estrogen is doing, let me digress a bit and talk a little bit about this concept of estrogen receptors. So this is a slide showing an artery, small artery, and within the artery, there's of course red cells and white cells and other things, but there's also all of our hormones. And I made this nice big E here. This is estrogen. And all of our hormones.
I love your E's and
I love my E's, my big red E's. So as estrogen circulates in the bloodstream, it will eventually find this kind of mirror image of itself depicted on the slide, which would be called the estrogen receptor for estrogen. And our cells have hundreds, if not thousands, of receptors for different things, like for other hormones like insulin, and for drugs maybe that we take for our blood pressure or whatever. But as these components circulate in our bloodstream, they eventually land on these cells, and that indicates that this complex is it indicates this, that if it happens to be a liver cell or a muscle cell or whatever, it tells us that estrogen plays a role, in that tissue.
Yeah, and every tissue and every cell is going to have a very specific functions, and estrogen is going to be helping each cell very specifically.
Exactly. And
so,
go ahead. Yeah.
Oh, I'm so sorry.
No, go ahead.
So if we focused on the brain, we know that estrogen is important in the brain. Do we know where estrogen receptors are in the brain?
Yes, we do. And this slide addresses that. The technology is amazing that we can actually identify specific areas in the brain where different hormones work. And this is a cross section of the brain, and the small dark dots and little triangles are estrogen receptors and progesterone receptors. We're focusing on estrogen receptors for this talk, but I'll just say that just about everywhere there's an estrogen receptor, there's a progesterone receptor. And you can see
there's a very important point, because I'm sorry to interrupt.
Yeah.
It's a very important point because people don't really know that, and we talk about estrogen because it's the main or estradiol, the main estrogen, but we have progesterone that work in synergy with it.
Exactly, and that's a whole nother talk right there. Hopefully we'll talk more about it, progesterone. And the point I want to make is not to burden people with a lot of anatomical names here, but just to show that there's some definite areas where the estrogen receptors are concentrated, and that implies that these particular areas are very dependent on estrogen, and estrogen plays a role. And consequently, when estrogen is low or deficient, you would expect that these areas may not function as well. And I have a slide here that maybe helps describe this a little bit more clearly. And that this area in green here, is my pointer showing that, Natalie?
Yes, it is.
Oh, great. So in this area in green is the hypothalamus, and it happens to be the area that makes the chemicals that go down to our pituitary, that go down to our ovaries, that regulate our menstrual cycles. So it makes a whole lot of sense, doesn't it, that the estrogen is going to have a huge role there.
Is it also, sorry to interrupt, is it also where we talk about the thermoregulation? So
exactly.
we will talk about that later.
Exactly.
When women talk about hot flashes, they don't realize that actually the area that is responsible for the hot flashes is actually located in the brain.
Exactly. And sometimes I take it for granted that people don't realize that, and that, it's no coincidence that estrogen receptors are highly concentrated in that thermoregulation area, and that there's obviously a brain mechanism for those hot flashes. The other areas.
I have another question, Sandy. So when we talk about receptors in the brain, estrogen receptors in the brain, are those receptors mostly located in the gray matter?
Yes. The gray matter, gray matter is kind of a funny term. It basically, I'll explain this a little bit later, is that there's gray matter and white matter, but the gray matter is kind of more the the business center of the brain and its activities, and the white matter is more kind of the connections, between those areas. And actually, a lot of people think the gray matter is just all on the top, up here, the cerebrum area. But all of these areas where estrogen works also would be classified as gray matter. But the other areas which, again, have a bearing on estrogen would be the hippocampus, which is very important. The big purple area here, very important in memory and learning, where when we see things and hear things and experience them, they're initially processed in that area, and then they'll go up through the white matter, to the cerebral area to kind of be analyzed. Actually, especially up here in this is the prefrontal cortex, where we do more of our complex thinking and problem solving, and actually personality is also moderated up there. And then, of course, there's the amygdala. A lot of people, I like that word, amygdala. It has a lot to do with emotional processing. So once again, estrogen is very important in all these areas, not only just in women, but in men. And once again, we'll be talking about it down the line, but when we don't have as much estrogen, it goes to reason that maybe some of these functions are going to be affected.
Mm-hmm. I see, like in the, how about, tell us where the serotonin is produced. Is it basal ganglia?
Good point. Yes. I should have brought that to everyone's attention. This area called the basal ganglia is where the bulk of the serotonin in the brain is made. So once again, it's highly dependent on having a good estrogen supply. That's a good point, Natalie.
Well, you had it on the previous slide. It's just that, you showed in color with the functions here. So I'm not very good in anatomy. That's probably why I didn't go to medical school. That's why we work together. I'm just looking at the molecular biology here and helping me put it in a bigger context. So that's really important. So yeah. So we know that there are estrogen receptors in all these areas of the brain. This amazes me. What exactly does estrogen do in these areas? And let's say, the molecular biologist in me, what's going on at the cellular level?
Yes. Once again, I think if women understand that, they'll have a better appreciation for how important estrogen is. So in order to answer that, let's just do, I know you don't like anatomy too much, but we'll have a little more. No, I know. So this is, the nerve cell is called a neuron. And this is a diagram of a couple nerve cells, and they consist of kind of a central body. And they have some little arms coming out of their bodies called dendrites.
With
and then
their nuclei, they have their nuclei in their blood.
Exactly, the brain of the brain cell, right? that's exactly true. And then this long protrusion is an axon, and that's how this works is that the impulse is either received or generated in the cell body, and then it transmits that down to the axon, where it interconnects with some of the dendrites of some other cells. And then the electrical impulse goes down, down, down. And then the way that it initiates another impulse, in a neighboring nerve cell, is through transmission of some chemicals through what we call a synapse. And those chemicals are called neurotransmitters. And I have a blow up of that slide.
Oh, so I love it. That is more like my world.
Yeah, yes, yeah. There's a lot we could talk about on this slide, but once again, we have our cell body, and then we have the axon, and then here's where this one interconnects with this one, and this is a big picture of the synapse. And at the end of the axon, there's these little bubbles that have little red dots, and those red dots represent the neurotransmitters. And then the neurotransmitters are released, and they go into the cell body of the next cell, which is this one, and then send a message down. And these neurotransmitters, I'm sure you're familiar with, and many people are familiar with. And as you mentioned earlier, one of them is serotonin.
I was going to say, could you name a few neurotransmitters, because people hear about them and then they don't necessarily picture how they influence neuronal communication.
Exactly. Depending on what transmitter is released, that triggers some other kind of action or reaction. And there's serotonin and acetylcholine and norepinephrine, which is kind of like adrenaline, and
dopamine.
I'm sorry?
Dopamine as well.
And dopamine. That's a very important
one. Happy one. I like it.
You're right. So the next slide, I think, is impressive, because first I'll say that we're born with about 100 billion neurons, and then each neuron can interact, has up to anywhere from a couple thousand to 10,000 synapses. I mean, to me, this is mind-boggling that each of these little dendrites and their little fingerlings can connect with a whole bunch of other cell bodies, and then simultaneously transmit this massive amount of information. And what I was trying to come up with was sort of an analogy, in that suppose it's July, it's a couple days before the 4th of July, right? You're walking down the street, and all of a sudden you hear this big bang behind you. You hear that big bang, and all of a sudden, your ears are listening. Maybe you smell something like a little smoke or something. You look around, and maybe you see a little kid running away, and
even worry about somebody else getting hurt.
Was it a gun? And you're going up to your higher cortex, prefrontal cortex, and saying, was that a gun? Was it a backfire? What was it? You kind of see the little kid. You put your reasoning together, and you think, oh,
should I be afraid? Should I leave?
Yeah, exactly. And you're also sending impulses to your heart and your lungs to do the fight or flight thing. So it just in a split second, all these synapses are sending things. I mean, it's mind-boggling.
It's fascinating to me.
Exactly. Yeah. So and we'll talk about this in one of our subsequent talks probably, but we are born with a certain amount of neurons, and they don't necessarily divide like other cells. So it's very important that we try to keep them as healthy as possible. And that's where estrogen plays a role.
So Are we, well, a lot of people talk about neuroplasticity. We'll get back to it about what it means in the subsequent talk. And
Exactly. Yeah, I
so
think, I mean,
what does estrogen do? So now we know where it's located in the brain. We know that it has a role in neurotransmitters and all sorts of communication within each neuron, between neurons. So what does estrogen really do?
yeah, that's again, I just love how we kind of approach this so analytically. We talked about the general anatomy, and then we talked about a little of the physiology, and now we're getting really down to the really, the biochemical sort of properties of estrogen. So
Does
estrogen,
estrogen keep our neuron healthy? I mean,
exactly, that, and I think I guess that's what I'm trying to hopefully convince convince women, that estrogen plays a huge role in keeping the brain healthy. And it does this in a couple of different ways. So you already introduced this concept of neuroplasticity, which a lot of people don't know what it means, but it kind of basically means that the brain can change. We're not born with a static brain. It's changing. It's developing new connections. And what's fascinating is that we didn't ever think that our brain would grow new neurons, but there's a lot of evidence that the brain can grow some new neurons in response to learning and to adapting to our environment. Because this down here is to represent a little stem cell, a little neuron stem cell that could develop into a new neuron. But more importantly, neuroplasticity is talking more about the making new connections. So we may have one neuron connecting with another one. These two aren't really connected yet, but it's conceivable that a connection can be made. And there's lots of different things being touted that can improve the ability of connection. Certainly, just stressing, learning, trying new things, repetition, all these things can help improve these connections. But estrogen is one biological agent that actually can improve these connections.
so are you saying that we can teach an old dog new tricks?
Exactly. And that's what learning is all about. And what happens over time is that these connections, if we don't use them enough, they can go away. But if we try to learn and force our brain to work and do new things, then yes, we can teach an old dog new tricks.
And it starts with awareness, and this is the reason, this is why we are doing this webinar. It starts with awareness of what happens and when, and it's not what I like about neuroplasticity. I have little great nephews and nieces, and so I'm looking at as they develop the first 3-4 years of their lives, they can learn so much. They're so neuroplastic.
Yeah.
And I tend to work with older people, and what I keep saying is that we can keep learning. We can keep learning.
Exactly. Yeah. I mean, little kids they have like 25,000 or 30,000. I mean, they're like neuroplastic little robots, making these connections, making them and keeping the ones that they want, and, discarding the ones they don't. But yeah, it never stops, really. And I think a lot of people don't realize that. So that's pretty exciting, all the research there. But that's just one thing that estrogen helps with. The next thing that estrogen is very important for, and again, this is actually in men and women. This is not just unique to women. We all need estrogen in our brains. And one of the other functions that estrogen does is it actually improves and actually facilitates the sugar, glucose, going into the cells. Our brain cells take up more glucose than the whole rest of our body. I think you've heard that. It just 80% of our glucose uptake is taken through our brain. So you need all sorts of ways to make sure that the cells are fueled, and estrogen promotes the fueling of our brain cells.
And as a biochemist, when I think glucose, I think, fruits and vegetables and not just, white sugar.
Right. Yeah.
But we'll talk about this later as well.
Yeah, that'll be the other thing. But as an aside, just to throw this out, that's something I don't know if we talked about earlier, Natalie, is that one of the issues with dementia and Alzheimer's is that if you don't have estrogen and other things that help the brains use glucose, then they start using the other things like fat, and that, as you know, when you utilize fat, you develop these ketones, and ketones actually kind of are toxic to nerve cells. So we want to be sure that we keep fueling these nerve cells with glucose.
Well, what a lot of people don't realize is, glucose is the energy, and the fat, the good fat, are actually that's what makes membranes when we talk about cells. So
Right.
when we talk about cells, the cell membranes are made of this phospholipids that are extremely but they protect the inside of the cells, and they're also very mobile and flexible, and that's where in the membrane, it's where we have the receptors for the estrogen and all sorts of receptors, calcium and all sorts of.
Exactly. Yeah. I mean, they certainly have their role, and I think what I hear from you too is that that's a secondary fuel for cells. We really would prefer certainly the brain to use glucose as its main source of fuel.
Yeah, well, if we want to be expanding, we need the energy to create those dendrites, and we need some lipid to make the membranes for those new dendrites.
Exactly. And then apart from the glucose uptake functions that estrogen promotes, estrogen also is plays a role in the production of the neurotransmitters, particularly serotonin, acetylcholine, and dopamine. And as we mentioned, those are three very important ones for brain function.
Yes.
And then finally, I'm not done yet on everything good that estrogen does.
So much.
Another extremely important property of estrogen, and not just in the brain, but throughout our body, is that it's a very strong anti-inflammatory and antioxidant chemical. People just don't realize that. They think more of like, vitamin C and vitamin E and those sort of things. Actually, estrogen is the new vitamin E. I should make a poster on that. But the brain, since the brain cells don't divide, like if we cut ourselves or have other injuries to any other part of our body, the body will replace those right away. But the brain doesn't have that facility to actually replace itself. As I mentioned, there's some stem cells that may produce some new cells, but that's a very limited thing. And so we got to do everything we can to keep our cells from being injured. And the estrogen
and it needs to remove the debris, created by oxidation and inflammation. And this is really a machine. I mean, the entire body, every organ is fascinating, but the brain, we really need to take care of it.
Yep. And that's the role. The other role that you mentioned is that the debris that, the cells are just like little bodies, they make some debris. They have some toxic byproducts, and those need to be removed. So you need good blood circulation in the brain to not only provide the fuel and the glucose and the oxygen, but to take away the debris. And that's again, we're going to get into this more in one of our future talks about Alzheimer's, is that one of the hallmarks of Alzheimer's is a buildup of this debris, known as plaque, the amyloid plaque. So anything that can help both fuel the cells as well as, act to get rid of any toxic products is going to help your brain over your lifetime.
To stay healthy. So, Dr. Rice, if I can summarize what you've described, estrogen does many things to keep our brain cells healthy. And when we have more and better, and when we have more and better functioning cells, our brain works better.
Exactly.
Simple, right? That's
Yeah.
just better. So if we can go back to those areas in the brain where there are a lot of estrogen receptors, can you comment on why perimenopause and menopause, where there is a loss of estrogen, may cause symptoms, and what symptoms?
Yeah, exactly. I mean, I think that we're coming full circle now. We've talked about where estrogen receptors are and where estrogen's important and how estrogen can keep those areas healthy. And so it goes on to reason that once we start losing estrogens or don't have enough, we may have some issues. And that comes back to what you were describing, is that in the areas where estrogen really plays a critical role, we're going to start having some symptoms. So in the hypothalamus without estrogen, we're going to have issues with temperature regulation, which is the underpinnings of hot flashes. We're going to perhaps have issues. We don't have as much serotonin, or the serotonin isn't working as well. That's going to affect our mood. The amygdala with the emotional processing and focusing, that may be affected with lack of estrogens, and
what we call brain fog.
Exactly. That's exactly where I was going with all this, is that, let's look at the symptoms. Hot flashes, yeah, we've covered that. We have an explanation for that. Mood swings, yeah, we have some pretty clear explanation for that. And then the brain fog, which, going back to the brain diagram, you're going to have brain fog if you're just not remembering things as well, you're not processing things as well, you're not relating things as well. So those are very characteristic symptoms of perimenopause. We didn't really, the next, to introduce our next talk, we're going to be talking more about cognition and what the lack of estrogen does as far as our long-term risks of dementia and Alzheimer's. So that's a whole nother talk right there, which I think people will find interesting.
Yes, I think we wanted to break it down because this is more the general, function, the role of estrogen, and we'll have 4 other modules where we will discuss. So the hot flashes, we discuss the thermoregulation, what it means, what can be done. We'll talk about the mood swings and the anxiety that a lot of women experience at midlife, and some, depression as well. So some things, we want to make sure that we put the right names on the right things. We'll also have, so the third module will be about brain fog and cognition. We'll talk about dementia and Alzheimer's in particular. There is a lot to say about this. And in the fourth module, what you and I have decided to do is to talk about the importance of lifestyle changes, and they could be very small changes, and they could really make a difference in it includes sleep and diet and exercise. And there is a lot to say about that to stay healthy.
And I think women realizing that paying attention to those things early in life, and especially going through the perimenopausal period, can make a huge impact in the future. So that'll be exciting things to talk about.
I think so. And the whole point of this presentation is really to educate or to bring awareness as early as possible, because it is possible to maintain a healthy body and a healthy mind as we age, if we know some of these little things, if we see how exercise affects the brain, or nutrition, affects the brain, or the sleep pattern and overall energy level. I think, we would ultimately, I would like to see more pre-menopausal, perimenopausal women notice the slight changes and act. Because every woman is going to be unique. And so we can help them seek support just specific to their needs.
Yeah. And education. That's, you know,
Education. It's
education
all
is
about
empowering.
education. So
Yep,
they can, once they know, they be able to advocate for themselves and ask specifically, you know, connect with specific healthcare providers for their specific needs and maintaining so they can age healthfully.
Well said. Thank you,
Thank
Natalie.
you, Dr. Rice. Thank you, Sandy.
Looking forward to our next talk. Thank you.